So now we're going to look at an example using geometric sequences to solve kind of a problem that we're going to get asked. So our sequence is the one you see right here, so 4, 12, 36, 108, so on. So it's going to keep going on. And they're asking us the following questions. So is the sequence geometric? We have to find t of n, we have to find t of 7, and which term is the number 78,732. Yeah? So I guess we'll just start with question 1. Is the sequence geometric? Okay, so the way we're going to find out if a sequence is geometric is t of n divided by t of n minus 1 is equal to constant. Okay, and if this rule is true, so if what we have written there is true, then it's geometric. So we have to test that. So what I'm going to do is I'm going to take t of 2 and divide it by t of 1. So we're going to say 12 divided by 4 is going to be equal to 3. And then I'm also going to divide 36 and take 36 and divide it by 12. So then t of 3 divided by t of 2. So I should just write that. That's going to be t of 2 divided by t of 1. And then as well, I'll go green. We'll say t of 3 divided by t of 2. And that's equal to 36 over 12. And that's also equal to 3. So because it's consistent between the first and the second and the third, then we know it's going to be constant. And we know that this means that it is geometric. Yeah, so that's the rule for geometric sequences. So that's the first question done. Give a green tick. Find t of n now is the next one we have to do. Alright, so you'll remember that t of n for a geometric sequence, part 2 here, t of n for a geometric sequence is given by the form a or to the power of n minus 1. Yeah, so we need a, which is the first term, and we need or, which is the common ratio. So I'll start with a anyway. A is just 4 because that's the first term in the sequence. So we have here that a is equal to 4, and now we need or, which is the common ratio, and this is actually what we got there as well. So I'll write constant, and it's also equal to the common ratio. So all we have to do is prove it's equal to that it's equal to a constant if we want to find out if it's geometric or not, and then also we can use that number to find the common ratio. So that means how much they increase by each time. So that means you multiply it by 3 every time, because that's the result we got when we divided t of n by t of n minus 1. So that means or, like I said, the common ratio, or is equal to 3, because that's the number we got when we divided t of 2 by t of 1, or t of 3 by t of 2, as we see here. So I'm going to write that, or is equal to 3, and now we can find our t of n. So I'll also write it over here. We're going to say that t of n is equal to 4 multiplied by 3 to the power of n minus 1. So that should be a 3. And there's our t of n. So that's our second part. Done. I'll do another green tick. T of 7 is the next part. So we just have to sub 7 into our formula here to find the 7th term. So that's what t of 7 means. It means find the 7th term in the sequence. So obviously instead of counting along and continuing this, it's much easier to use the general term and just sub 7 into where there's an n. Yeah, so t of 7 is equal to 4 multiplied by 3 to the power of 7 minus 1. So that's equal to 4 multiplied by 3 to the power of 6, and then you're gonna have to probably use your calculator for that. So 3 to the power of 6 will give us 729. So it's 4 multiplied by 729, and that again is going to be equal to 2,916. So that's t of 7. We'll give ourselves a nice green tick for that one too. And the last one then is which term is 78,732. I'll rush on and do this one here. So the number, like I said, is part 4, 78,732, and we have to find which number term that is. Okay, so which term? So where is it? This is the first term, the second term, third term, fourth term. It's going to keep going until eventually it reaches 78,732. We want to find out which number term that is. So basically we're going to call it t of n, and we need to solve for t of n. So the method we're going to do is we're going to say that's equal to t of n, yeah? Or another way of saying that, so I'm going to write that. We're going to have, say t of n is equal to a or multiplied by n to the power minus 1 is equal to 78,732. But we know what a and or are, so we can rewrite this. We can say that's 4 multiplied by 3 by n to the power minus 1. So that is our t of n that we found earlier. for this particular sequence, and we're going to let that equal to, ooh, that's a weird equal to, 78,732. And now we have to solve this, okay? So again, we might need logs for this, so I'll just write that here. You might need logs. So if you haven't done logs yet in school, then don't be so worried about the end of this method. Yeah, basically you need to revise your logs if you want to solve this. So what I'm going to do is we need to basically get n on its own and get it down from being an exponent. So first I'm just going to divide across by 4, so to get rid of the 4 on the out here. So divide this side by 4 and divide this side by 4. That 4 will cancel with that 4, and we're left with 3 to the power of n minus 1 is equal to 19683. Yeah, and now this is where the logs come in. So I'll go red for this. So we're going to take the log of both sides. So I'll just write that here. I'll say log of both sides. So we're gonna have, I'm going to take the log base 3, okay, of 3n minus 1. Let's put that in bracket there, is equal to log base 3 of, that should be in bracket, 19683. Here we go, okay? And so I'll have to continue this over here on the right, but just if you're not comfortable with logs, then you might not be familiar with this, but yeah, if you haven't done it yet, then basically you'll have to wait until you do logs to solve problems like this. But hopefully if you have done logs, you can follow this question. So I'll continue it over here. I'm just going to write it again. So we have log base 3, 3n to the power minus 1 is equal to log base 3 of 19683. So what we can do with logs, we can take this exponent down, so n minus 1, we can take it down in front of the logs. So I'll do that in orange, and I'm going to say that's equal to n minus 1 multiplied by log to the base 3 of 3, and that's equal to log to the base 3 of 19683. Yeah, log to the base 3 of 3 is just 1, so that means on this side we just have n minus 1 is equal to log to the base 3 19683, and so now we just have to put that into our calculator, that n is equal to 1 plus log to the base 3 of 19683. We put that into our calculator and we're going to find our answer that log is equal to, or sorry, that n is equal to 10. So that means the 10th term, so let me scroll back up, there we go. So the 10th term in our geometric sequence, so this is the first, second, third, goes all the way up to 10th, is going to be 78732. Yeah, and that's our first question done on geometric sequences. Hopefully you enjoyed it, and we're going to have 1 or 2 more videos, so we'll see you next time. Don't forget to like and subscribe if you enjoyed them.